All right, guys, 5.3, we're solving trig equations. Everything that we're doing today, everything that we're going to do today, you guys know how to do. We're going to solve equations. We're going to use the unit circle and find stuff, all that good stuff. We're just putting everything together, okay? We're going to think algebraically, and we're going to work trigonometrically. I think I just made that word up. Can we remind ourselves, please, of a couple things? On the unit circle, when we look on the unit circle, x value of the ordered pair is cosine, right? The y value of the ordered pair is sine, correct? And then y over x with our ordered pair is tangent, correct? When we're on the unit circle. And then we have our reciprocal functions. We're going to focus on these right now, but your reciprocal would be secant, cosecant, and cotangent. But we'll talk about that in a second. So we're going to solve these equations just like we would any normal equation that you guys have seen a million times. All right? Look at this first example. First example says to solve, yes? Do you guys see how it says solve 2 sine x minus 1 equals 0? We're solving. We are not solving for x by itself. We're solving for the sine of x. This is together. I want to get that by itself. So what would I do?
Divide by 2.
Not yet. Hold on. It's the first thing we need to do. Add 1 to both sides. Good. So I'm going to add 1. I get 2 times the sine of x equals 1. Again, we want sine of x all by itself. So what do? Divide by 2. Good. So I end up with the sine of x equals 1/2, right? Nothing major there. If we're referring to the unit circle, which we will be doing, the sine is what value, x or y? It's your y value of your ordered pair. You're fine. So now what we're going to do, guys, you're going to go to the unit circle, which I'm going to give you. And you are going to find all the ordered pairs that have y value of positive 1/2. Okay? So I'm going to go over here. Where is my y value positive 1/2? Tell me where. Pi over 6. And where else?
5 pi over 6.
5 pi over 6. That's the answer to your equation. X equals, what was it? Pi over 6?
Pi over 6 and 5 pi over 6.
And 5 pi over 6. That's it. That's it. We solved our equation, right, for the sine of x. Then we went to the unit circle and we found where all of the y values were positive 1/2, and we found our answers. Questions? It doesn't get much harder than that, I promise. Look at the next one. Find all of those solutions over the interval of 0 to 2 pi. Everything we do is going to be over the interval of 0 to 2 pi. So if I was going to solve this equation, you want to get all your variables on one side and your numbers on the other, right? So I'm going to rewrite this. I'm just going to write underneath here. Sine of x plus the square root of 2 equals negative sine of x. Well, if I want my sine of x's to be together, I got to move one of them to the other side, correct? So you want to subtract over here? Minus the sine of x minus sine x. You guys agree? Okay, so I have the square root of 2 equals what? Negative 2 sine of x's. Good. Now I want the sine of x by itself. I want the sine of x all by itself. Divide by negative 2. So this says sine of x equals negative root 2 over 2. Well, remind yourself, guys, sine is what value on the unit circle? Sine is the y. So you're going to your unit circle, and you're finding where all of the y values are what? Negative square root of 2 over 2. So go over to your unit circle. And this is real easy to mess up here, so pay attention. Which one's x, which one's y? Where are the y values negative root 2 over 2? 5 pi over 4, good, and 7 pi over 4. So your answer is x equals 5 pi over 4 and 7 pi over 4. That's it. All right, what do we notice about this one? It's got a squared. What else do you notice? It's tangent. Think about it. As soon as you see tangent, what should you think of? Y over x. Good. So look, we're going to try and get, not try, we're going to do it. We want tangent squared of x by itself. So what are the two things algebraically I need to do? Add 1. So 3 tangent squared x equals 1. Now what?
Divide by 3.
Divide by 3. You guys are awesome. So tan squared x equals 1/3. I don't want tangent squared. I want just plain old tangent. So how do I get rid of a squared? You take the square root. Good. When you take the square root, what goes in front of your answer? Plus or minus. Okay. Guys, what's the square root of 1? 1 over the square root of 3. Can I leave my answer like that? No. So I have to rationalize, right? So I'm looking for all the places on the unit circle where the tangent of x is the square root of 3 over 3, correct? Now, this you got to do a little bit of thinking. Just look at the first quadrant, because everything's the same all the way around, just the signs are different. So in the first quadrant, is the tangent, what's the tangent right here? The tangent is 0, is what? Y over x is going to give me 0 over 1, which is 0, correct? Okay. What's the tangent right here of pi over 2? Y over x, which is what? Undefined, okay. So it's not that ordered pair. What's the tangent here at pi over 4? Root 2 over 2 divided by root 2 over 2 gives me 1. So it's either 1/2 root 3 over 2 or root 3 over 2 1/2. All right, this is probably a good thing for you guys to memorize. But if I were going to figure this out, I have root 3 over 2 divided by 1/2, right? Root 3 over 2 times 2 over 1. What's the tangent when 1/2 is the x value and root 3 over 2 is the y value? The square root of 3. So over here, where 1/2 is the x value and root 3 over 2, what's the tangent there in the second quadrant? If it's positive root 3 here, what is it here, guys? Negative root 3. What is it here? A negative divided by negative is a positive. What is it here? A negative. It's the same thing all the way around, just the signs are different. So when root 3 over 2 is first, what's the tangent? Root 3 over 3. Because if you work it out, 1/2 divided by root 3 over 2, right? 1/2 times 2 over root 3. What happens? 1 over root 3, then you got to rationalize. So that might be something that you guys want to try and memorize. When root 3 over 2 is your x value, your tangent is root 3 over 3. When 1/2 is your x value in your ordered pair, your tangent is just the square root of 3. If you don't memorize it, it's no big deal. You just work it out. But I'm looking for all the places on the unit circle where my tangent is positive or negative root 3 over 3. So I know for sure it's here at pi over 6, right? Where else is it? Where the square root of 3 over 2 is the x value. 5 pi over 6. Where else? The x value has to be square root of 3 over 2. 7 pi over 6. And where else? 11 pi over 6. So you have 4 answers. X equals pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Now again, if you don't memorize that, not a big deal. Just remember to find the tangent, you put the y value over the x value. All right, look at this one. Where would we even begin here? Where should we begin, you think? Should we, if we're factoring, should we try and get everything on one side?
Yeah.
Okay, so let's just do that. Let's just move everything over. A cotangent of x times cosine squared of x. When I move 2 cotangent of x over, it becomes what? Negative 2 cotangent of x equals 0. All right, do you see, there's 2 terms there. Do you see that they have anything in common? Okay, they both have a cotangent, right? So I can take the cotangent out. I can factor it out. If I take out cotangent here and cotangent here, I'm left with what? Cosine, whoops, squared of x minus what?
2.
Minus 2 equals 0. Okay, deal. We okay? All right, now that we've factored, we have it set equal to 0. You set each piece equal to what? 0. So I have cotangent x equals 0 and cosine squared x minus 2 equals 0. Well, ladies and gents, if tangent is y over x, what is cotangent? X over y. I'm going to look on the unit circle to where when I put the x value over the y value, I get 0. Well, where is that? When I put the x value over the y value, I get 0.
Pi over 2.
Okay, pi over 2. 0 over 1 is 0. Agreed. Anywhere else?
3 pi over 2.
Right? If I put 0 over negative 1, do I get 0? Okay, so it's pi over 2 and 3 pi over 2. Good. So over here, x equals pi over 2 and 3 pi over 2. Perfect. So now let's solve this one. Cosine squared x minus 2. What do I do? Add 2. Okay, so cosine squared x equals 2. Now what? I take the square root. So I'm looking for all of the values on the unit circle where the cosine of x is plus or minus the square root of 2. What is cosine again? X value. Are there any x values on the unit circle that are just either positive or negative square root of 2? This is not a trick question. Do you see any x values that are just square root of 2 or negative square root of 2? No. So guess what this is? Undefined. If it said cosine x equals 12, is there any part of the unit circle that has an x value that is 12? No. It's not a trick question, guys. Is it part of the ordered pair? No. So then it does not exist. All right, let's keep on trucking. What do you guys notice about this problem? It's long, okay, so therefore it's probably so hard we just cannot do it, right?
It's squared.
Just look at it. Can you get sine? It's a quadratic. Very good. That says 2x squared minus x minus 1. Can you factor this? Absolutely. 2 times negative 1 is negative 2. Guys, what times what will give me sine squared? Sine times what? Okay, deal. Are there factors of negative 2 that could multiply to give me negative 2, but add to give me a negative 1?
Negative 2 plus
What?
Negative 2 plus.
I'm trying to get negative 2, right?
Yeah.
So then factors of negative 2 that'll add to multiply to give me negative 2 but add to give me 1. Negative 1. So I have negative 2 and a positive 1, right? Back to factoring from the beginning of the year. Is my A term 1? No, so I have to divide both of these by 2, right? Just 2 divided by 2, nice and pretty? Yeah. So this first parenthesis becomes sine x minus 1. Agreed? My second parenthesis becomes what? 2 sine x plus 1 equals 0. Guys, after you factor and you're trying to solve, what do you do with each piece you factored? Set it equal to 0. Perfect. So sine x minus 1 equals 0. 2 sine x plus 1 equals 0. Now think about this. Sine. Sine is what value? Y. Okay, so we're going to be looking for y values on the unit circle. Let's just go ahead and solve this. On the left-hand side, what do? I'm going to add 1. So sine x equals 1. So I'm looking for y values on the unit circle that are 1. Go to your unit circle. Where are the y values? Positive 1.
Pi over 2.
Just one of them, pi over 2. So x equals pi over 2. Perfect. How do I do that second equation? I'm going to subtract 1. Good. So 2 times the sine of x equals negative 1. Now what? Divide by 2. So the sine of x equals what? Negative 1/2. Remind yourself, sine is the y value. So we're looking for y values on the unit circle that equal what? Okay, where are they? The y values. 7 pi over 6, good. And 11 pi over 6, perfect. X equals 7 pi over 6 and 11 pi over 6. Now, would this be a lot more difficult if you did not, or if you were not given the unit circle? If you were required to memorize the unit circle? Yes. We are going to give you the unit circle on your test. You will not be required to memorize it. So it'll be just like this, just a bunch of problems where you're just solving equations and then finding the values on the unit circle. All right, what do you guys notice about this one? It's a quadratic, but there's 2 different trig functions. We did a couple of these when we were doing our simplifying and stuff, and I told you a little trick. When you have a quadratic and there's 2 different trig functions, you have to convert one to the other. Always try to convert to the middle, because we have a Pythagorean identity that'll help us do that. So I have sine squared, right? I have sine squared. Can I change sine to cosine? Yes. Do I have a Pythagorean identity?
1 minus cosine.
There you go. Right? This is our Pythagorean identity that we use a million times. What can I change sine to? I can, if I subtract cosine from both sides.
1 minus cosine.
Right? You guys agree with me that sine equals 1 minus cosine? Yeah. So all I'm going to do is take my 2 right there, and instead of sine squared, I'm going to write 1 minus cosine squared. And then finish the problem. Plus 3 cosine x minus 3 equals 0. Whenever you guys are given a factoring problem that has 2 different trig functions, always look to a Pythagorean identity. You will be able to convert to the middle function, to the function that's to the first power. Now we just go back to algebra, guys. What do I do with that 2? I'm going to distribute it in. Yep, I knew what you meant. 2 times 1 is 2, right? 2 times negative, so I have minus 2 cosine squared x plus 3 cosine, whoops, forgot the s there. Cosine x minus 3 equals 0. Do you guys see anything that you can combine?
The 2 and the minus
2 and the negative 3. So I have negative 2 times the cosine squared of x plus 3 cosine x minus 1. Agreed? Is this now a quadratic? Yes. What's the one thing I don't like about it, though? It leads with a what?
negative.
Leads with a negative. Do we ever factor, guys, when we lead with a negative? No, so just take it out. How do I do that? Just divide everything by -1. So 2 cosine squared x. This becomes minus 3 cosine, right? And this becomes +1 equals 0. All right, now we can just factor like normal. What times what is going to give me cosine squared? Cosine and cosine, perfect. What value on the unit circle is cosine? X, good, okay. And then I have to multiply a times c here. 2 times 1. What are the factors of +2 that multiply to give me a +2, but when I add, I get a -3?
-1 and -2.
-1 and -2, or -2, -1, however you want to look at it. Can I go ahead and just solve right here? Or am I missing a step? We have to do what? We got to divide, yep, both factors by a, good. So now, guys, I have cosine x minus 1/2 equals 0. And I have cosine x minus 1 equals 0. Almost done. No, because you took it out. Remember, good question. This -1, we set it equal to 0. It doesn't, because it doesn't have an x with it. So now let's move the 1/2 over. I have cosine x equals 1/2. So I'm looking on the unit circle for what values? X values that are positive 1/2. Go to your unit circle. Positive 1/2. Pi over 3 and 5 pi over 3. Good. So x equals pi over 3 and 5 pi over 3. Good. And I have some more answers, right? I have to move 1 over. So I have cosine x equals 1. I'm looking for, again, x values.
0.
X values, good. That are 1. So where is my x value? Positive 1. 0. What's another one? Also, you could say 0 or 2 pi. Same place, right? Either one. Either one. Okay. No, because we're going to go like this. You like that?
Yeah.
You like apples? How about them apples? All right. This next one. This is a teeny bit different. I'm going to rewrite it because what happens when I write t's in a problem? They start to look like plus signs. Then we all get confused. How is this problem a tiny bit different from all the ones that we've done? They've all had x's. There's a 3. Okay, this is called a multiple angle. There's one extra step here. It's still super duper easy. You cannot separate that 3. Do you guys see how it's in between the trig function and the variable? So you have one teeny little extra step. I want to get cosine of 3x by itself. So I'm going to do what? I'm going to add 1. Good. So I have 2 times the cosine of 3x equals 1. Again, we're trying to get this all by itself. So now what do? Perfect. So cosine 3x equals 1/2. I don't do anything with that 3x just yet. Remind yourself, guys, cosine is what values? All right, so we're looking for x values that are positive 1/2. So let's go over here and look. X values positive 1/2. Pi over 3 and 5 pi over 3. So in all of the other problems, we wrote x equals pi over 3. And then we had x equals 5 pi over 3, correct? But guys, it's not x equals, is it? It's 3x. So you have one little extra step left to do. Well, now you got to solve it. How do you get x by itself? Divide by 3. Watch. Please don't make this silly mistake. If I divide by 3, I'm divided by 3 over what? 1, right? So we're going to keep, change, flip. So I have pi over 3 times, when I flip 3 over 1, it becomes 1 over 3. So my answer here is pi over what? 9. You're fine, you're fine. Whenever you have a coefficient of the x in your problem, whenever you find your values on your unit circle, instead of saying x equals, you just put that like 2x, 3x, x over 2, whatever. You just solve it. One little extra step. So same thing here. We're going to divide both sides by 3 over 1. So I keep, change, flip. I have 5 pi over 3 times 1 over 3 gives me 5 pi over 9. Good. Very good, guys. All right, this last one we're going to solve. Oh, this one just looks too hard. I'll give you the unit circle, and I will give you your identities for your test. So first things first, we need to get everything where? On one side. So I have secant squared x minus 2 times tangent of x minus 4 equals 0. Agreed? Okay. We have a quadratic, so we're going to factor. And I told you, when you have a quadratic, you can always change to the middle function, correct? Now, I know some of you don't have your identities right in front of you, but does anybody remember what secant squared is the same as?
1 plus tan.
1 plus tangent. Perfect. So 1 plus tangent, I'm going to rewrite that, minus 2 tangent x minus 4 equals 0. Now can we solve this?
Yeah.
Super. Good job, guys. I can add the 1 and the negative 4 and get what? So tangent squared x minus 2 times tangent of x minus 3 equals 0. So let's factor. What times what is going to give me tangent squared? Tan and tan. My a term is 1, so this is super easy. What times what gives me a negative 3 when I multiply, but a negative 2 when I add? Plus 1, right? And minus 3. Everybody with me? Okay. So I'm now going to say, okay, fine. I have tangent of x plus 1 equals 0. And I have the tangent of x minus 3 equals 0. Solve both sides. Subtract 1. So I'm looking where the tangent of x is negative 1. Well, remind yourself, guys, how do you find tangent? It's the y over x values. So go over to your unit circle. Okay, your unit circle. And you're looking for the values where you put y over x to equal negative 1. So think about, guys, in order for something to be 1, you divide by itself. So our ordered pairs that are root 2 over 2, our ordered pairs that are root 2 over 2 are going to give us a tangent of 1 or negative 1. Since I want it to be negative 1, it has to be one positive value and one negative value. So that is going to be our 3 pi over 4 and our 7 pi over 4. So your answer here would be x equals 7 pi over 4, and we said 3 pi over 4, right? And 3 pi over 4. Now over here, I have tangent x minus 3 equals 0. We're going to add 3 to both sides. So I have tangent x equals 3. Again, tangent is our y over x values. So you go to your unit circle and you say, where are the y? If I put the y value over the x value, am I going to get positive 3? That's not going to happen anywhere, guys. So this would just be undefined. You can cross it out and just say undefined. So for your WebAssign homework, you're going to, I put it in the directions, but make sure you guys see it. You're going to just convert it to a PDF and do all of your work, answer everything, write on the PDF, and then submit it. You do not have to enter anything into WebAssign. Tomorrow you will have class time to work on it, so feel free to do that, but I would get started tonight.